I am Dr. D.K.Tripathi, Assistant Professor of Physics under the Department of Basic Science and Humanities. We have discussed in detail about the stimulated emission in the last class. In the stimulated emission, what happens that if the atom in the excited state absorbs, then it comes down to the ground state with release of energy before completion of its lifetime. The amount of energy released here is double the amount of energy released by one atom in the spontaneous emission. So it is highly beneficial to us. One very important thing about this is that photons are liberated highly in the same direction. So two photons which will be liberated will move in the same direction. Now if these two photons will go and collide with the other two photons in the excited state, then four photons will be liberated and these four photons will move in the same direction. Now if these four photons will go and interact with the four atoms in the excited state, then eight photons will be liberated. Now if these eight photons will go and interact with the eight atoms in the excited state, then 16 photons will be liberated, and these two photons were highly coherent. Due to that, all these photons will be highly coherent because their frequency as well as the wavelength is same and their amplitude is nearly same, and they are liberated by the same atom. So thus they are maintaining the coherency property. Now what we conclude that if these photons which are liberated will define a light, then this light is called as laser light, and this laser light will be highly directional, highly, as frequency is same, so only one frequency is there, so they will be highly monochromatic. All the photons adds up, so because of that they will be highly energetic. They are maintaining the coherency property. That means coherency we have discussed in the case of interference. So due to that they are highly coherent, they are highly energetic, their penetration power is very high, they are having the tight focusing property, and they also gives us continuous output power. So we conclude that this stimulatedly emitted light is highly beneficial, which we call as the laser light. So thus we conclude that laser light is highly coherent, highly directional, highly monochromatic, highly energetic, has high spectral purity, it is giving us continuous output power, and it can give us tight focusing between ordinary and laser light. As we have seen that the stimulatedly emitted photons in the laser light are moving in only one direction, so laser light is highly directional, whereas in the ordinary light the photons are released in all possible directions, so because of that it is not having the directional property. In the laser light there is high peak power and large energy per pulse is in the pulsed output laser, whereas in the ordinary light the power of ordinary light is very high. Laser light is highly monochromatic, whereas ordinary light is having a wider range of frequencies. Laser light can be focused in the area proportional to wavelength square, whereas ordinary light cannot be focused proportional to wavelength square. Laser light is highly coherent, whereas ordinary light is non-coherent. Laser light is having high energy, rather than that ordinary light is having less amount of energy. Laser light can penetrate deep into the metals, whereas ordinary light cannot go up to that in the metals. So these are the characteristic differences between the ordinary light and the laser light. Difference between spontaneous and stimulated emission. As both of these are emissions, so we must know that what is the difference between them. In the case of spontaneous emission, what we have seen that the atoms are de-excited after completion of its lifetime to the ground state with release of energy, whereas in the case of stimulated emission, the atoms from excited state got de-excited under the influence of external energy by interacting with that and comes down to the ground state with release of energy. In the spontaneous emission, the photons liberated in all possible direction, whereas in the case of stimulated emission, the photons are liberated in one direction. In the case of spontaneous emission, the external energy is not required for coming down of the atoms. Atom is completing its lifetime, and that is why it is coming down to the ground state, whereas in the case of stimulated emission, photons are required, as well as we can say that external energy is required to trigger the atoms in the excited state so that they can come down to the ground state. In the case of spontaneous emission, the energy liberated is less than the energy liberated in the case of stimulated emission, whereas in the stimulated emission, the energy liberated is greater than the energy liberated in the case of spontaneous emission by the atoms, molecules, ions or particles which is coming down to the lower state or ground state. The spontaneously emitted light is having high energy compared to the stimulatedly emitted light, whereas the stimulatedly emitted light is having the higher amount of energy but less than the spontaneously emitted light energy. In the case of spontaneous emission, the photons which are liberated is non-coherent, whereas in the case of stimulated emission, the photons as well as the light defined by them is highly coherent. Spontaneously emitted light is having less penetration power. The penetration power of the stimulatedly emitted light is high enough. These are some of the references which you must pursue to know more about the topics. Thank you.